Guys, this is Malinki. Welcome back to my channel Voice of Malinki. Today we will talk about spectrophotometer, and if you are new in my channel, please subscribe my channel, and if you like my video, please do like, comment and share my video. So what is a spectrophotometer? So the spectrophotometer is an instrument which measures the concentration of an unknown chemical. So suppose you have a chemical in your hand, you have a solution and you don't know its concentration. So you can measure the concentration of that particular chemical, and by using spectrophotometer you can do that. And basically it measures how much light a chemical substance absorbs. Principle of spectrophotometer. So every chemical substance absorbs light over a certain range of wavelength. The spectrophotometer works by passing a light beam of a particular wavelength through a sample and measures the intensity of absorbed light. So let's try to understand this principle in this picture. So here a spectrophotometer consists of a light source, a collimator, it is basically a lens, then monochromator, that is a prism, a wavelength selector, or you can say it a slit, cuvette where we can place our test sample, then here it is the detector and a digital display. So light source is transmitting light here, which is focused in this monochromator via this lens. Basically this lens or collimator is placed between the monochromator and light source because it focuses lights in this monochromator or in this prism. Now monochromator is basically a prism which splits light into several component wavelengths, or you can say spectrum, because this is the function of a prism. So prism is splitting the light into the several component wavelengths, and then it is the wavelength selector or slit. So it transmits only the desired wavelength, which is, you can see, which is yellow in this case, and then it passes through the sample solution. So here it is the sample solution that is present in the cuvette, and this yellow light is passed through the sample solution to the detector, and the detector detects amounts of absorbed light and sends a signal to the digital display. A spectrophotometer can select a variety of wavelengths because different chemicals absorb different wavelengths of light. So based on your sample, you can select the wavelength here in the instrument, and the wavelength will be selected by the wavelength selector that will pass through the sample. And now we will see the calculation part, or how the spectrophotometer measures the concentration of your sample. So now transmittance T is equal to IT by I0. So I stands for intensity. So number of photons per second is called the intensity of light. So here IT is equal to light intensity after passing through cuvette, and I0 is equal to light intensity before passing through cuvette. And absorbance A is equal to minus log T is equal to minus log IT by I0. So absorbance is the amount of photons that is absorbed. Now from this absorbance that is A, we can determine the concentration of the given sample by using Beer-Lambert law. Now, according to Beer-Lambert law, a linear relationship exists between absorbance and the concentration of a sample. So, here absorbance A is equal to absorption coefficient into L into C. So, here A is equal to absorbance. Absorption coefficient is denoted by epsilon. Then L is equal to path length and C is equal to concentration. So, absorption coefficient is basically constant. It describes how much light of a particular wavelength is absorbed by a material of a given mass and thickness. And path length means, that is L. It means how much distance a light requires to pass through a cuvette. So here we can say this is the cuvette. So here it is the I0 and it is IT. And this is the length of a cuvette, that is L. So the light requires to pass through this path, this is L. And this is generally 1 centimeter. So from this equation, we can calculate the concentration of a sample. Now types. So depending on the light source, spectrophotometer could be of two types: UV visible spectrophotometer and IR spectrophotometer. So UV visible spectrophotometer uses visible light, that is the 400 to 700 nanometer range, and UV light, that is 185 to 400 nanometer range. And IR spectrophotometer uses infrared light, that is having the range 700 to 15,000 nanometer. Applications of spectrophotometer. So spectrophotometer is used for quantitative analysis in various areas such as biochemistry, biotechnology, physics, chemistry, clinical as well as industrial applications, material and engineering, chemical engineering, etc.